Calculating work. Now, from my last lesson, we learned about what entails having to do with work and the scientific definition for work. Today, what we're going to do is we're going to calculate work, and that's using the equation work equals force times distance, shown here. Now, last lesson we talked about force, and we know that force is measured in newtons. In this case, for distance, we're just going to keep it measuring in meters just for simplicity. And work would be measured in joules. And so the international system unit of measurement for work is joules. And just keep that in mind. So if we go back here, we have work measured in joules. Force, as you all know, is measured in newtons. And it's multiplied by distance, which is measured in meters. Of course, distance can be measured in centimeters or kilometers, but in this case, just for simplicity, we're just going to measure it in meters. So let's tackle a problem. So here's one. If James applied a force of 10 newtons to push a box 5 meters, how much work did James do? And so we're given our formula, which you should have written down, which is work equals force times distance. Now, the first step is to rewrite that formula. The second step is determine what we are going to solve for, and we're solving for work. Are we given force? Yes. We plug in all the things that we are given now. So force is 10 newtons, and we know it's multiplication because we're multiplying force times distance to get work. And the distance is 5 meters. M stands for meters. The third step is to solve the problem. And so we rewrite that again, work equals, and you just multiply 10 times 5, and you get 50, and the letter J stands for joules. That's how you solve for work. Let's look at another example. Beth applied a force of 5 newtons to pick up her books 0.5 meters from the desk. How much work did Beth do to pick up her books? So the first step is to rewrite the formula. The second step is to plug in anything that were given to us. And so that is work equals, the force is 5 newtons multiplied by 0.5 meters. And the third step is just to solve the problem. So if we multiply 5 times 0.5, we get 2.5. And don't forget that unit of measurement, which is the letter J for joules. So work equals 2.5 joules. Beth did 2.5 joules of work to pick up her books. Here's another, the last example. John carries his backpack 30 meters from his class. How much work did John do? So if you go through the process of rewriting the formula again, work equals force times distance, you come to find out once you plug in the information on step 2, we are missing force. And so in this case, John actually did not do any work because he didn't apply force to his backpack. Because he didn't apply force to it, he would not be working. Even though he's carrying his backpack, he's not actually applying force to the backpack. Therefore, he's not doing work based on our scientific definition of work. So we learned how to calculate for work, and now what we can do is calculate for force. So once again, we work with this formula, work equals force times distance. In this case, we are going to solve for force. And what I do here is I draw a dotted line, an imaginary line down the equal sign. And so now we're dividing this formula into two left and right side. On the right side of this formula, the right side of the equal sign, force is multiplied by distance. And what we need to do is we need to isolate force. And when we do that, we actually have to move distance over to the other side of the equal sign. And because we move distance to the other side of the equal sign, we have to divide it because the other side of the equal sign is opposite of the right side. So work divided by distance equals force is the formula for force when we calculate for force. Let's take a look at this example. The amount of work is 75 joules to mow the lawn for a total of 15 meters. How much force did you exert? And so the first step is to rewrite the formula above. Work divided by force equals distance. The second step is to plug in the numbers that are given to you. And so work here is given as 75 joules. We divide that by the total distance, which is 50 meters, and we get force. And so the last step is to just solve the problem. 75 divided by 50, it's 1.5 newtons. And so it's 1.5 newtons of force to mow the lawn 50 meters using 75 joules of work. Let's look at another example. A robot does 33 joules of work to vacuum the floors 10 meters. What is the amount of force that the robot exerted? So first step is to rewrite the formula. In this case, I'm not going to rewrite it for the sake of not having enough room. So I'm just going to jump into the second step, which is to plug in the numbers. And so 33 joules is given to us. We divide that by 10 meters and we get force. The last step is to solve for force. So all we do is 33 divided by 10 and we get 3.3 newtons. N stands for newtons. And don't forget that unit of measurement for force. The last thing we're going to do is we're going to calculate for distance. Now, we're going to rewrite the formula work equals force times distance. And this time, we're going to solve for distance. Now, if you remember from the last part of this video where we solved for force, what we had to do was we had to divide work divided by distance because we're moving distance to the other side. In this case, we're going to be moving force to the other side. And so our formula is going to look something like this. That should look familiar to you from how we solved for force. So it would be work divided by force equals distance. That's the formula for distance. Let's look at an example. If a dog pulls a sled with 76 newtons of force and does a total of 506 joules of work, how far did the dog travel? So the first step obviously is to rewrite the formula work divided by force equals distance. The second step is to plug in the numbers. So let's do that. So we have work as 506 joules divided by force, which is 76 newtons, and we get distance. The third step is to solve the problem. And when we do that, we have 6.66 meters, approximately 6.66 meters. And so the dog pulled the sled 6.66 meters.